On the second one, the questions were a little differently. So you're trying to dunk a basketball. You need to jump 2.5 feet off the ground. This can be modeled by this equation. So this is tracking how high your feet are getting up off the ground. So we're going to follow the same idea as we did with max revenue and as we did on the last problem. So what is your initial velocity? So remember, the initial velocity is this middle term. So because the initial velocity is positive 12, it's going to be 12 feet per second. And it's going to be going up because positive 12 is positive. What is the starting height? So we have no C term here. There's no plus any number. So that means the height is 0 because you're starting off the ground. So because you're starting off the ground, it's 0. All right, calculate the time it gets to the max height. So negative b over 2a. So remember, standard form. Negative 16 is a, 12 is b. Over 2 times our a value, which was negative 16. Oops, wait, our b value was 12, sorry. And it's negative because in our equation here, we have negative b. That's what we'll do. Let's take that, put it in the calculator. We get 0.375. It's going to take us 0.375 seconds to get to the max height. So we're not jumping very high. Now to find the max height, same as max revenue, we calculated the time to get there. Now we multiply, plug it in. So let's take the original equation. I'm going to replace the t's with a 0.375. Get rid of that extra t. And we get 2.25. So that's how high our feet get off the ground. Now the basketball is 2.5 feet. We only ever reach 2.25. So we never reach the 2.5 we need to dunk. So it's going to be no, because we only jump 2.25 feet when we need to jump 2.5 feet. So obviously we need to work on our jumping abilities.